So if you can remember, we have been doing stoichiometry, isn't it? Right? Isn't it? Right? We have been doing something called as stoichiometry, where I gave you information about one of the reactants or products, and you are able to find the information about the other reactants and products in the equation. Right? So I told you what and all. I told you first thing what you have to do is you have to make sure that you have to balance the chemical equation before you start the problem. Right? You have to balance the chemical equation before you start the problem, isn't it? And after that, from the stoichiometric equation, I'll be able to write some terms. What to say, for example, if it is H2 and O2, right? I can say that for 1 mole of 2 moles of H2, 1 mole of O2 is getting formed, and 2 moles of H2 is getting formed. All that we saw. We even did some example problems, isn't it? Right? Okay. Now I told you at the last end of the class, I told you that now till now all the reactions which you saw, right? I gave only information about only one of the reactants, correct? Right? But there can be cases where more than one information is given. That is, if I have say H2 or O2 giving reacting to form H2O, the information about both H2 as well as O2 is going to say as well as O2 is going to be given, and they'll ask you to find what is the number of moles of H2O to be formed, right? So in that case, I told you sort of something. I introduced you to the term called as limiting reagent. Do you remember? Right? Okay. If you don't remember, again we're going to see that only. No problem. Right? So how what is the analogy I gave you? Say for example, for me to make a human body, right? I require 2 legs and 2 hands, right? Say if at all I have 4 legs and 4 hands, I'll be able to make 2 human bodies. Say if at all I have 6 legs and 6 hands, I'll be able to make 3 human bodies. Now these are this 6 and 6, 4 and 4, 2 and 2. All these are the required exact amounts, right? But say I have 5 hands and 6 legs, right? I have 5 hands and 6 legs. Now what will happen with the 6 legs? I expect to form 3 human bodies, but I have only 5 hands with me, so I will not be able to form 3 human bodies. I'll be able to form only 2 human bodies. I'll be able to form only 2 human bodies because I have only 5 hands, right? So 4 of the hands will go, 4 of the legs will go. Correct? Are you able to understand what I'm telling? Right? So definitely in those cases, you will not. You have to use something called as limiting reagents, right? So we'll take an example now, right? Say let me take the example of this. Right? Say I have N2 plus 3H2 giving 2NH3. Right? N2 plus 3H2 giving 2NH3 is the equation I have now. Right? Say I give the informations to you like this. I have say 68 grams of N2 is there, right? And say I have 4 grams of hydrogen, right? I have given you 68 grams of N2 is present, and 4 grams of H2 is present, and they're asking you what is the mass of H2O formed. Sorry, what is the mass of NH3 getting formed, right? Now, what did I first tell you? First, convert everything in terms of number of moles. Whatever data is given to you, convert them into number of moles. That's what I told you. So let me convert this into number of moles, right? So can I say for this, the number of moles value would be 68 divided by 34. That is N2's mass, or molecular mass of N2 is 34. 17 is the atomic mass of nitrogen. Two atoms of nitrogen are there, so it will become 34. So can I say it will be 2 moles, right? So I have 2 moles of nitrogen, correct? Okay, now I'll do the same thing for H2. Now can I say it will be 4 divided by 2, and again I have 2 moles of H2, correct? 4 divided by 2 will become 2 moles of H2. So I have 2 moles of N2 and 2 moles of H2, right? Now if you look at the stoichiometry, 1 mole of N2 requires, so I'll write it like this, 1 mole N2 requires 3 moles H2, right? So now how many moles of N2 I have? I have 2 moles of N2. So how many moles of H2 is required? Number of moles of N2 required will be 4 for me to complete the reaction. Sorry, 6 moles. isn't it? So 1 mole of N2 requires 3 moles of H2. So 2 moles of N2 will require how much? Into 2 will become. So it will become 6 moles. I require 6 moles. But how many moles I have in the picture? I have only 2 moles, right? So obviously it is the case of the last case I told you, 5 hands and 6 legs, isn't it? I must have something, but that particular amount is lesser than what is required, isn't it? So what you see is that for 1 mole of N2 from the stoichiometric equation, I can say that for 1 mole of N2, I require 3 moles of H2. So how many moles of N2 I have? 2 moles of N2 I have. And obviously I require how many moles now? 6 moles I require. But how many moles I actually have for H2? I have only 2 moles of H2. Right? So whenever you see that a particular component is not up to there to the required amount, that particular compound or element is going to be called as a limiting reagent. Right? With that particular compound or the component is going to be called as limiting reagent. Very, very important. Okay, fine. Now, say I'll do the opposite now. Right? I didn't, with respect to N2, I calculate H2. Now, say if I do like this, okay. So for 3 moles of H2, I require, for 3 moles of H2, I require 1 mole of N2. So how many moles of H2 I have? 2 moles of H2 I have, right? So how many moles of N2 is required? Say if I put X, right? So for 3 moles, 1 mole, for 2 mole, it will be, so if I cross multiply, I will get 2 by 3 moles. Correct? Right? So for 1 mole of, for 3 moles of H2, I require 1 mole of N2. Right? So how many moles of H2 I have? 2 moles. But what I require is 2 by 3. But how many moles of N2 I have? And 2 moles of N2 I have. Isn't it? The requirement of N2 is only 2 by 3 moles. But how many moles of N2 I have? 2 moles of N2 I have. So this is more than what is required. Right? So whenever you see the particular component is number of moles or amount is more than what is required, that is what is called as excess reagent. Right? That is what is called as excess reagent. So again, I repeat, limiting reagent means it is lesser than what is required, right? And sorry, limiting reagent. And excess reagent means it is more than what is required. Okay. And what and all other things you have to know about limiting reagents. Now see, if at all I want to calculate the amount of products, right? If at all I want to calculate the amount of NH3 to be getting formed in this case, like or in any of the reaction, first you find which is the limiting reagent, right? First you find which is the limiting reagent, and you will do the stoichiometry of the products with respect to only the limiting reagent, because that is what is in the required amounts. Basically, the other one is more than what is required, isn't it? So you see that in this case, I have 2 moles of H2. With that only, I have to go for what to say? Information is given to you. First step is to find which is the limiting reagent. Okay. After finding limiting reagent, then the problem is over. You don't have to care which is my excess reagent, right? And then do the stoichiometry with respect to the limiting reagent and find the amount of products getting formed. Right? So here, after all, you want again, I'll repeat. For 1 mole of N2, I require 3 moles of H2. How many moles of N2 I have? 2 moles of N2 I have. So how many moles of H2 is required? 6 moles of H2 is required. But how many moles of H2 I have? I have only 2 moles. So that is my limiting reagent. So if I do the opposite, for 3 moles of H2, I require 1 mole of N2 and I have 2 moles of H2. So actually, I will be requiring 2 by 3 moles of N2 only, right? But how many moles of N2 I have? 2 moles. So N2 is my limiting reagent. So in this case, H2 is the limiting reagent. Sorry, correct. And N2 is my excess reagent. Okay, fine. Now I wanted to tell you, after finding out limiting reagent, you can directly go for the stoichiometry of products with respect to only and only the. Understand? Fine. So now what I'll do the stoichiometry, right? So I have for 2 moles H2, I form 3 moles of H2. For 3 moles of H2, I form 2 moles NH3. Now, how many moles of H2 I have? I have 2 moles. So, what will it be? Can I say it will be so 4 divided by 3? So, X will be what? 4 divided by 3 moles of ammonia is getting formed. So, here I have 4 by 3 moles of ammonia getting formed. Right? Okay, so I can calculate the mass. So 4 by 3 into 17 will be the molecular mass of ammonia, and that will be the mass of NH3 getting formed. Guys, do you understand? Tell me yes if you understand.
Yes, sir.
Okay, what about others?
Yes, sir.
Yes, sir.
Oh, is there anyone who didn't understand? You want me to repeat again? Is there anyone like that?
No, sir.
Okay, fine. Anyways, we'll do one more example. Then you'll get a little bit more hold of this. Okay. Now I'm going to give you the information. Okay. Say I have 17 grams of N2. Okay, 17 grams of N2, and I have uh, 6 grams of H2. Okay, I have 17 grams of N2 and 6 grams of H2. Right now, I want you to find what is the number of moles of, or what is the mass of ammonia getting formed. Quickly do it and tell me the answer. First, tell me which is the limiting reagent, and then we'll move on. Do it. Tell me first which is the limiting reagent here and which is the excess reagent, and then we'll move on.
N2, sir.
Correct. N2 is the limiting reagent, right? Okay, fine. Now go for the product formation. How much will be the amount of product formed? NH3 mass. I want everyone to try. Please do not just look at the video. Take your notebooks and solve. Oh, let me do this. I think I have to do this. Guys, open up your videos. Show me your face. Ah, you don't have to show me your face. Just show me at least your notebooks, please. I want to see it. Okay, first I'll call out by names. Nikhilesh, just show me your face or show me your notebooks. Okay, Nikhilesh. Suryamuthu. Okay, thank you, Nikhilesh. We'll switch it off. Suryamuthu.
Yes, sir.
Can you just show me your notebook, please?
Yes, sir.
Okay. Subiksha, thank you, Niklesh. Sorry, thank you, Surya.
Yes, sir.
Okay, fine, thank you. Fine,
Thank
next.
you, sir.
Harshita. Okay, Harshita, fine. Thank you. You close it. Siddesh. Okay, Siddesh. Fine, thank you. Muthu Krishna. Sorry, Mithun Krishna. I'm sorry. Mithun Krishna. Okay, fine. Thank you, Muthu. I don't know who is this HP. Is that the laptop? Okay. Okay, HP, fine, HP. Thank you. Subiksha. SN Subiksha.
Sir, I already shown.
Okay. Showed me. Sorry. Yes. Pranav Jagannathan. Okay, Pranav. Thank you. Abhishek M. Okay, Abhishek. Cool. Thank you. Atul. What happened, Atul? You're not able to show?
1 second, sir.
Yeah, sure. So in that time, Shruti, can you show? Okay, Shruti. Okay, Atul. Fine, cool. I'm sorry, guys. I'm making you do like this, but the thing is, I really want to know whether you are working out or not. Please work out, right? There is nothing wrong in working out. If you don't get the answer, it's completely fine. Okay. If you don't get the answer, it's completely fine. I don't mind at all. But the thing is, you should be trying. That's the point. Okay. Even if you don't get the answer, even if you don't tell, even if you're wrong, even if you know that it's going to be definitely a wrong answer, but you can put it out on me. I will take care. Is that okay? Fine. Cool. So as someone said here, N2 is going to be the limiting reagent. We'll see how, right? Okay, fine. So what do we do first? We'll go for the finding the number of moles. So can I say it will be 17 divided by 17 is 1 mole, right? And 6 divided by 6, sorry, 6 divided by 2. Oh, sorry, 17 divided by 34, right? Sorry, guys. 17 divided by 34 is 0.5 and 6 divided by 2 will become 3 moles. Okay, now I can easily tell this. For 1 mole of N2, I require 3 moles of H2. Now, if I have 0.5 moles of N2, how many moles of H2 is required? For 1 mole, 3. So can I say half a mole, 1.5 moles? Correct? Now look at this. How many moles of H2 I have? I have 3 moles of H2, but how much is required? Only 1.5 moles of H2 is required, isn't it? So can I say H2 in this case will be my excess reagent, more than what is required is there? Right? H2 will be my excess reagent, and in this case, N2 will be my limiting reagent. Isn't it? Now what you have to do? forget about the excess reagent and go only with the limiting reagent. So I don't care about H2 now. So for 1 mole of N2, I get 2 moles of ammonia. So half a mole of N2 will give me what? 1 mole of ammonia. And I know 1 mole of ammonia will be 17 grams. That's the answer. Understood? Right? Okay. I think everybody understood. Now, please understand that at the end of the reaction, if you see, right, I'm going for the end of the reaction. Say now what will happen? The limiting reagent will be completely consumed, right? It will become 0 basically. At the end of the reaction, the number of moles or the mass of a limiting reagent will become 0. But even after the reaction is over, you will see that there will be some amount of, H2 left. That is my excess reagent left. So how many moles of H2 will be left? I require only 1.5 moles, but I have 3 moles. So even after the end of the reaction, I will have 1.5 moles of N2 to be left out. Isn't it? So 1.5 moles, I know what will be the mass. 1.5 moles will be 1.5 into 2 will become 3 grams of H2 will be still remaining even after the reaction. Right? This can also be a question. They can ask you that find the amount of products, right? And they ask you to find how much is the amount of excess reagent left out after the reaction is over. That can also be a question. So what you have to do, just take the required amount and make it react, and you know how much is not reacting. Calculate the mass. Understood? Right? Okay. Fine. Now we'll do one last example. Move on to problems, proper problems. Right. Okay. So I'm going to take this reaction H2 plus O2 giving 2H2O, right? Okay. Say I have 64 grams of O2, right? And say I have 4 grams of H2, right? Now quickly tell me which is the limiting reagent, which is the excess reagent. Do the stoichiometry. Go for it. This much time. Yes, Nikhilesh.
What's the excess rate?
I'm not able to hear you.
Sir, oxygen is the excess reagent, sir.
Oxygen is the excess reagent. Yes, correct. Right? Okay. So we'll see how it is. Okay. So now if I calculate the number of moles, 64 divided by 32 will be the molecular mass of O2, 16 into 2. So it will become 2 moles, right? And here what I have, 4 divided by 2, that is the molecular mass of H2, will become 2 moles. Correct. Now look at this. For 2 moles of H2, I require 2 moles of O2. So, correct. Right. So for 2 moles of H2, I require 2 moles of O2. So if I have 2 moles of, am I doing it correctly? Okay. So if I have 2 moles of H2, I require only 1 mole of O2.
The molecular mass of O2 is 16. Right?
One oxygen is 16, Kanna. I have O2, so it's 32. Okay, fine. So what I was telling, okay, so for 2 moles of, I write it like this, right? So for 2 moles H2, I require 1 mole O2. Now I have 2 moles of H2, no problem, right? So how many moles of O2 is actually required? Only 1 mole of O2 is required. But how many moles of O2 I have? I have 2 moles of O2, so definitely it is more than what is required. So O2 is my excess reagent here, right? And obviously H2 is going to be my limiting reagent. Okay, fine. So now what will happen? I have to do stoichiometry with respect to the limiting reagent only, because excess reagent is going to be left out even after the reaction. Okay. So for 2 moles of H2, I require form 2 moles of water. So I have 2 moles. So I have 2 moles of water getting formed. So obviously I know 2 into 18 will be the mass, which is 36 grams of water is getting formed. Understood? 36 grams of water is getting formed. Right? Okay. Now, like if I ask you what is the mass of O2 left, right? So I require only 1 mole of O2, but I have 2 moles of O2. So after the reaction, 1 mole from this would have reacted. So still 1 mole remaining, isn't it? For O2, still 1 mole will be remaining, and 1 mole of O2, I know how much it will weigh. 1 mole of O2 will weigh 32 grams. That is the answer. Understood, right? Okay. Now the questions can be still more little made interesting, right? So what do is they give everything. So now you know how to do stoichiometry, how to find the limiting and excess reagent, and how to do the stoichiometry with respect to the limiting reagent. All that you know, right? Say now you are assuming, actually in all these cases you are assuming that the reaction is 100% completed, right? You're assuming that the reaction is 100% completed. Okay, say now in this case, for example, I tell you that it is not 100% completed, it is only 80% completed, right? I say the yield of the reaction, they say, right? The yield of the reaction is only 80%, not 100%. It is not 100% completed, it is only 80% completed. That means what? It's very simple. Do everything till now whatever you did, right? Say now if at all I find out that how much is the mass of H2O getting formed? 36 grams is the mass of H2O getting formed. This is for 100%. I assumed that the reaction is going to completely get over. That means what? After the end of the reaction, this 2 moles would have become 0. Isn't it? 2 moles of H2O, limiting ratio would have been completely consumed in the reaction, right? But if I say 80%, right? The trick is like this. Do everything with respect to 100%, assuming that it is 100%. And then you can go for cross multiplication. How would you cross multiplication? Say, for example, now how do I like this? For 100% of completion, I form 36 grams of H2O. Right now, what will you do? For 80%, find X. That's it. Cross multiply and find out. So you will find it will be 36 into 80 divided by 100. Done. That's it. So 36 into 8 divided by 10. That is what is the answer. You will find it to be less than 36 grams. Okay, so this kind of questions can also be asked, right? So if nothing we are doing extra here. As now, if at all some percentage yield is given to you, do not worry about it. Just do the stoichiometry as you know it for 100%. After the end, just one more thing you have to do. Just do the cross multiplication for 100%. This much for whatever the person given. What is the amount? You find it. Okay. Understood, guys? Okay. Fine. Now we are going to do some problems. Go for it. Okay. Take down this question. 17. Okay, if you've taken this down, I'll give you the question. Right. Take down. 17 grams of ammonia, 17 grams of ammonia is mixed with the same mass of 17 grams of ammonia is mixed with same mass of HCl. Mixed with same mass of HCl, right? The question is, find the mass of NH4Cl. Find the mass of NH4Cl. So the reaction goes like this. NH3 plus HCl gives NH4Cl. That is the reaction. Yes, quickly tell me the answer. They are given 17 grams of NH3 is mixed with the same mass, that is 17 grams of what is that, HCl, and they want to know what is the mass of NH4Cl getting formed. Now obviously both the informations are given, it's not only one information, so you have to find the limiting reagent and excess reagent. That's only to the problem. This much time, actually not required. Which is the limiting reagent here, guys?
Sir, NH3, sir.
NH3, are you sure? Okay, so basically I have 17 grams of NH3 and 17 grams of HCl, correct? 17 grams of NH3 and 17 grams of HCl. So I know this is 1 mole, 17 divided by 17 will become 1 mole of NH3, right? And for HCl, it is 17 divided by 36.5. How 36.5? For hydrogen 1 gram, for chlorine 35.5 grams, isn't it? So it will be 17 divided 36.5. Definitely it will be what? It will be around how much?
For ammonia also 20 should come, no, sir. 17 by 20 should come, no, sir.
17 by
20 should come.
Oh, guys, I'm sorry. Okay, like we did some mistakes. The atomic mass of nitrogen is 14, not 17. Right, I'm sorry. Like when we did the ammonia problem, I took it as 17. I'm sorry, it is not. It is what is that? 14 is the atomic mass of nitrogen. Anyways, all the problems, the approach, the way of doing all that was correct. But only the mistake was I took the atomic mass of nitrogen as 17. It's actually 14. Okay, I'm sorry. Right. Okay, so here it will be definitely less than 1. So I said it will be, if I calculate.
0.4.
Did you calculate how much is this? 17 divided by 36.5?
0.46.
0.46 moles. Thank you. Okay. So 0.46 moles. Now I can easily say which is the limiting agent now. Tell me. Guys.
HCl.
HCl.
Correct. So for 1 mole of NH3, I require 1 mole of HCl. I have 1 mole of NH3, but how many moles of HCl I have? Only 0.46 moles. So definitely, or I would say like this. For 1 mole of HCl, I require 1 mole of ammonia. I have 0.46 moles. So definitely it should be 0.46 mole, but it is more than the value. That is 1, right? So definitely NH3 is my excess reagent and my HCl is my limiting reagent. And that's it. Now after doing this, I can easily go for what is the number of moles of product formed. So for 1 mole of HCl, I form 1 mole of NH4Cl. So for 0.46 moles, can I say 0.46 moles? Right? And 0.46 into the molecular mass, that is 14 plus 4, 18, 18 plus 30, 18 plus 30 is 48, 48 plus 5 is 53, 53.5. Right? So 0.46 into 53.5 is the answer. Right? Got it? Right. One more problem. Right. Take it down. .5 moles of BaCl2. If you're calculating, I'll give you 1 more minute if you're copying it. Okay, the question, right? 0.5 moles of BaCl2, 0.5 moles of BaCl2 is mixed with 0.2 moles of Na3PO4, sodium phosphate, right? 0.5 moles of BaCl2 is mixed with 0.2 moles of Na3PO4, right? They're asking find the number of moles of barium phosphate getting formed, Ba3PO4 twice. Right? Find the number of moles of barium phosphate getting formed. When there is no mass, it's directly given in terms of number of moles, so the problem is still more easier. I expect many of you tell the answer. So hope you write the equation. The equation is very simple. This is a double displacement reaction after that I studied in 10th class, isn't it? So barium chloride will react with sodium phosphate to form barium phosphate, that is Ba3PO4 twice plus NaCl. Correct? So I have to put a 2 here, not 2. Okay, 2 here. Balance it. And I have to put a 3 here. Is it balanced? No, it's not balanced. So 3 bariums, how many chlorines? 6 chlorines. I put 6 here. Done. Now is it balanced? Right. 3 bariums, 6 chlorine, 6 sodium, yeah, balanced. Okay, yes. So they're telling 0.5 moles of BaCl2 and 0.2 moles of Na3PO4. They're asking you what is the number of moles of Ba3PO4 getting formed.
0.1 moles.
0.1 moles. Yeah, I think it is correct. We'll check it again. We'll check it. Right. So they have given 0.5 moles of this and 0.2 moles of this. Okay, I can easily tell, isn't it? So for which is okay, which is the limiting reagent here? First, tell me. Look at it and tell me.
Sodium phosphate.
Sodium phosphate is the limiting reagent. Good. Right. Say how. So for 3 moles of N2, I require 2 moles of N2. Sorry. For 3 moles of BaCl2, I require is required, and my Na3PO4 is the limiting reagent, and that's it. Right. Now I can do the stoichiometry now. So for 2 moles of Na3PO4, I form 1 mole of Ba3PO4 twice. So for 0.2 moles, I'll form 0.1 moles. So 0.1 moles is the answer. Yeah, whatever answer you gave is exactly right. Right? Okay, easy question. Next question. For the reaction, this reaction, that is Fe2O3 plus 3CO gives 2Fe plus 3CO2. For this reaction, 480 grams of Fe2O3 was taken. 480 grams of Fe2O3 was taken with excess CO, carbon monoxide, with excess CO yields, YIELDS, yields 252 grams of iron. Yields 252 grams of iron. They're asking you what is the percentage yield. The question is what is the percentage yield. I told you how percentage yield works, isn't it? Right. So first calculate. I'll repeat the question. For this reaction, 480 grams of Fe2O3 was taken with excess of CO. They themselves have given at CO is the excess reagent, so you don't have to care about CO. Right? Yields 252 grams of iron. Okay. Now they're asking what is the percentage yield of the reaction, and the atomic mass of iron is 56. Atomic mass of iron is 56. Can you do it? So first calculate for 100%. Just don't imagine that all the percentage yield is right. Just calculate for 100%. Right? And so now if you calculate some value for 100%, whatever the value you will get, some value you will get, and you know how much is the amount getting formed in the question. The question they have given that it is basically 252 grams. And this amount will be definitely different than this. So you can find the x value, and this x value is what is my percentage yield. Are you able to understand? Right? Go for it and tell me the answer. So for 100%, whatever value you do the stoichiometry, you have to find this value, right? And for 252 grams, what will be the percentage? X. Hope you guys are calculating and not looking at my face. My face is not that good. Please look into your notebooks since to do it. This much time? Anybody is gonna give me the answer?
So 75%.
How much? 75%?
Yeah.
Okay, I think it's correct. Anyways, I'll also check. Nice work. Okay. So they have given for 80 grams of Fe2O3, and I don't care about CO because they themselves have given that it is excess. It is an excess, right? So I know the molecular mass of Fe2O3. If you calculate, can I say it will be 160 grams 56 into 2 will be 112. 112 plus 48 will be 160. Right. So this is 3 moles. Correct. 160. What 480 divided by 160 is 3 moles. Right. Okay. Now for 1 mole of Fe2O3, I form 2 moles of F2. Sorry, Fe. Right. And for 3 moles, how much? So for 1 mole, 2 mole. For 3 moles, can I say 6 moles of Fe is getting formed? Right. So I calculate the mass for 6 into 56. So which will be 300. 300 plus 36 will become 336. What is it?
It's the 3.
336 only. Okay, correct. So I found 336 grams of Fe. This is for 100%. Assuming that the reaction is going to become 100% completed. Now, see, look at the value they have given for iron. They are given that only 252 grams of iron is getting formed. So now do what I told you. I'll do like this. So for 100% completion, I found out that 336 grams of Fe is getting formed. So if I have only 252 grams of Fe, what will be the percentage completion? Yeah, I think it is 75%. The answer. Understood, guys? Right? Okay. Next question. First, take this down, and then I'll give you the next question. Okay, ready? I'll give you 100 ml of 100 ml of a 20.8 m by v 20.8 m by v percentage 100 ml of 20.8 m by v percentage BaCl2 solution is mixed with 50 ml 50 ml of 17.4% m by v. 50 ml of 17.4 m by v percentage of K2SO4 solution. Of K2SO4 solution. The question is, find the mass of white precipitate formed. Find the mass of white precipitate formed. Okay, repeat the question. 100 ml of 20.8 m by v percentage BaCl2 solution is mixed with 50 ml of 17.4 m by v percentage solution of K2SO4, right? K2SO4 solution. They're asking you, find the mass of white precipitate formed. First, tell me what is the white precipitate here, guys? What is the white precipitate they are talking about?
Barium sulfate.
I'm not able to hear you.
Barium sulfate.
Barium sulfate.
Correct. Barium sulfate is the white precipitate, right? So first write the reaction, again a double displacement reaction, write the reaction, balance it. And then here it's just that they are giving you in terms of mass percent, m by v percentage. So you can calculate the mass, isn't it? How do you define m by v percentage? Someone tell me. How is m by v percentage defined? Hello. Forgot.
Mass of solute present in 100 ml of the solute.
Exactly. Mass of the solute present in 100 ml of the solution. Correct. So for BaCl2, they have given 100 ml of 20.8 percentage. So can I take 20.8 itself as the mass, because they have in 100 ml, and how do I define it? Mass of that solute present in 100 ml of the solution. So 100 ml is only given to you. So basically, what is the weight now? 20.8 grams of BaCl2 is present. That is what is understood. Right. Same way for K2SO4 solution, they have given 17.4 percentage. Now that means what? 17.4 grams of K2SO4 is going to be present in 100 ml of the solution. Right. But what is the volume now? Only 50 ml. So for 100 ml, 17.4. For 50 ml, it will be half of it. So 17.4 divided by half of it will be something. Right. It will be 8.57. Something you can calculate.
8.7.
8.7. Yeah, 8.7. Correct. Yes. Now you can do the problem. Balance it. Don't forget to balance it. BaCl2 plus K2SO4 KCl. Yeah, balanced.
Sir, what is the atomic mass of barium, sir?
Oh, wait. I'll give you atomic mass of barium. Tell me 1 second. One second, guys. I'll tell you the atomic mass of barium. One second. Yeah, it's 137. Guys, atomic mass of barium is 137. For potassium, it is 39. barium 137, potassium 39, sulfur 32, chlorine 35.5. Right. So basically, I have 17.4 grams of this. You continue. I'm just trying for myself. Barium is seven, 8.
Sir, I'm getting 101.48 grams.
101.48.
No.
101 is not the correct answer. So 0. Anyways, I'll tell you one second. So it will be 117. Yeah, this is the answer. 11.75 or 11.65 will be the answer. Okay. Now, how did I do it? It's very simple. Okay. Now, this is the reaction, guys. Okay. Fine. So, I know that 20.8 grams is present now in 100 ml. 20.8 is present, and 100 ml was given to you. Correct. So, for 20.8 grams, and the molecular mass of BaCl2 is 208. I calculated. So, how many moles I have? 0.1 moles I have. Okay, fine. When I go for K2SO4, they have given 17.4% solution. That means 17.4 grams in 100 ml solution, but I have only 50 ml. So what is the given mass? Half of it, that is 8.7. And the molecular mass of K2SO4 is 174. So I found out the value to be 0.05 moles. So obviously 1 mole requires 1 mole, right? So 0.05 moles will require 0.05 moles, but I have 0.1 moles. So definitely my K2SO4 is my limiting reagent. Correct. And I just forget about it. Now I'll directly go for BaSO4, that is my white precipitate, right? So 1 mole of K2SO4 gives me 1 mole of BaSO4. So 0.05 moles will give me 0.05 moles. That's it. Now 0.05 into the molecular mass of BaSO4, 137 plus 32 for sulfur, 64 for 4 oxygen atoms. That's it. If you calculate, 233 is the molecular mass of BaSO4. So the answer would be 11.75 grams. Understood, guys? Right? So we'll do little more amount of problems, and then we'll continue next class. Okay. Thank you so much. We'll meet again. Thank you, sir. Yeah. Thank you.